Well, good afternoon, everyone. Welcome to this, our inaugural seminar in the Capture Seminar Series. My name is Jim House. I'm a professor at the University of Manitoba in the Department of Food and Human Nutritional Sciences. And today it gives me great pleasure to introduce our first speaker in the seminar series and also the lead on the Capture training program, Dr. Mike Nickerson. Dr. Nickerson received his BSc honors in marine biology and an MSc in food chemistry, as well as a PhD in food chemistry from Dalhousie University in Halifax, Nova Scotia. Currently, he is the Saskatchewan Ministry of Agricultural Research Chair and Professor in the area of protein quality and utilization within the Department of Food and Bioproduct Sciences at the University of Saskatchewan. His research area focuses on improving the use of plant protein ingredients within the food industry, with emphasis on fractionation, ingredient modification, and protein functionality. His program has led to 160 plus internationally peer-reviewed publications, and he receives funding from provincial, federal, and industrial sources. Dr. Nickerson's program focuses heavily on graduate student training to meet employment gaps within the protein sector. And that's in essence the goal of the Capture program, which Dr. Nickerson will mention during today's talk. Just as a bit of housekeeping, if you want to ask a question during today's session, please use the chat feature on the associated with the WebEx platform, or you can save your questions until the end of the session and there will be an opportunity for Q&A at the end of this presentation. But for now, please join with me in welcoming Dr. Michael Nickerson as he presents on the topic of future opportunities for plant protein research in Canada.
Thanks, Dr. House. My name is Mike Nickerson, and as Dr. House mentioned, I'm a Saskatchewan Agricultural Research Chair in the area of protein quality and utilization. My research program really focuses on looking at the quality of the feedstock, wet and dry fractionation technologies, modifying protein functionality to achieve certain quality attributes and performance attributes in food products, as well as some high-value applications such as using the proteins to make microcapsules for controlled delivery vehicles. So today I was going to give my view of where the protein space is going in Canada. Try to look through the horizon, and this is based on a lot of global trends, research in my program, as well as some of my colleagues across Canada. So we're trying to get a bigger picture of where protein science is going in Canada. So I'll touch on a lot of these aspects today. As you know, plant proteins or plant-based foods are more than just a fad. They're a huge market trend being driven by industry and consumers. I did a quick Google search on plant-based foods last night, and I think there was over 2 billion hits just for a quick search. So it's all over the marketplace, consumer-driven, industry-driven, starting to move away from animal proteins towards plant-based or alternative sources. So when we look at the protein ingredient market, it's valued at about 52 billion in 2020 and expected to rise to 70 billion by 2025. So this is both animal proteins, plant proteins, and alternative proteins. So even though this talk talks about the trends towards plant proteins, it should be recognized that animal proteins is also increasing at a good rate as well. But when we look at the global plant protein market by 2022, so next year, it should be worth about 10.8 billion. It's increasing at a stronger rate than the animal proteins, but it is a much smaller section of the total global protein market. When we look at pea, and pea is obviously quite important and well known in Canada, that's expected to hit 39 million by 2022. So pea market compared to, say, soya or wheat is small, but it's growing at a big rate. The total protein consumption is supposed to double to 943 million metric tons by 2052. So the world demand for protein is increasing at a good rate. So what's driving these trends in the protein sector? Now here are some macro drivers. Global population growth. So how is the how are we supposed to feed 9 or 10 billion people by 2050, up from 7.5 billion today? So what new protein sources, what quality of the protein sources are we going to need to push into to feed that growing population? Population in developing countries is going to be stable, but there's going to be significant growth in China, rest of Asia, and Africa. So we really need to focus on plant protein, alternative protein, but also animal protein as well to feed this growing population. Another driver is environmental sustainability and ethics. So consumers are now looking for more environmentally friendly, more sustainable protein sources. So that's some of the push moving away from the animal protein markets towards plant proteins or alternative protein sources. And then urbanization. So we have rural people moving into our urban centers, and that's changing their dietary habits towards more animal-based protein diets, higher protein diets, and from different sources. Some other big changes that are driving the boom in protein are changing demographics. So millennials represent about 27% of the total population, but in China and Asia, it's 58%. These millennials are staying at home longer, so they have more buying power. Not to mention that they're very concerned about the environmental sustainability piece, the clean label piece, and are looking for alternative sources. So it's branching out beyond animal proteins. We also see a rise in the middle class, which also has a lot more buying power to drive more protein sources into the marketplace. Now, as we talk about animal proteins, they have some health risk associated with their consumption. So this is one of the drivers towards plant-based sources. It could increase risk of cardiovascular disease, perceived risk of mad cow or antibiotics. So there's a driver towards the plant-based or alternative protein sources away from animal in some of the trends. And regulatory influencers. So this is a good example is Canada's food guide, where they started to reduce the amount of dairy and replace it with some plant-based sources such as legumes or pulses in their diet. Other countries like the Netherlands are considering a meat tax, whereas other countries such as China are changing the dietary recommendations to consume less meat protein in response to alternative sources. There's some other micro drivers driving the protein trends in the industry. The flexitarian movement. So these are consumers that actively choose to eat less meat and then consume more plant-based sources or alternative sources of protein. So they actively do it, but they don't exclude meat from their diet. Rising costs of animal proteins has been a driver towards cheaper plant-based sources and clean labels. So how can we develop more clean label ingredients for the industry? When we look at some of the big market segments for the plant protein industry, meat analogs or substitutes are projected to be 7.5 billion by 2025. So that and the global dairy alternative drink market projected at 37 billion by 2025 are the big ones. So non-dairy alternative drink market, we're seeing some movement in non-dairy or cheese alternatives as well. But plant-based meats and the dairy alternatives are the big market segments right now for the plant protein for industry. You also see plant proteins creeping up in nutrition for sports, weight management, or supplements. Pharmaceuticals, so they're using plant-based sources to make controlled delivery vehicles for bioactive compounds, and cereals and snack foods as well. When we talk about beyond food, the feed market is also quite big for the plant protein market. Aquaculture feed is expected to reach 80 billion by 27, and the companion animal is projected to reach 113 billion by 2025. This is really evident if you go into the grocery store. You almost have one whole aisle dedicated towards companion animals, and you're seeing a lot more plant-based protein being used in the feed applications. So there's a number of challenges the protein sector in Canada is facing. Regulation, labor shortage, infrastructure really hamper the growth in the protein sector, and we're making some headway in terms of addressing some of these challenges, which I'll talk about throughout this webinar. Regulatory methods for measuring protein quality differ across countries, and this really impacts labeling. We'll talk a little bit about protein quality in a few other slides from now. But labeling is a big regulatory issue that we need to deal with in Canada. And then there's limited resources to support processing, such as water and energy, and that impacts environmental sustainability. So where these big plants are being erected have a big impact on the resources available to them. But this creates quite a few opportunities for the Canadian protein sector. Although soya proteins dominate the market, there's a growing demand for pulses and alternative protein ingredients in the market. So people are trying to move past soya, and pulses, for one, are a really good source of protein, highly functional alternative to soya. Another big opportunity, as you know, is Canada is mainly producing and exporting commodities elsewhere, and they get processed elsewhere. So building infrastructure and investment, which we'll talk about later in the webinar, is really important to start value-added processing here in Canada and retaining some of that added value that we see being lost just by exporting the commodities. Another opportunity is research investments, which is kind of the focus of the webinar, in which we'll touch on processing, ingredient modification, product performance, and so what investments in research and where are the opportunities that we see moving forward. Advanced training at universities to help address the labor training gap. So we'll talk about this particularly in reference to the Capture program, which is sponsoring this webinar series, and how we're trying to generate and develop new generation of graduates to fill these employment needs. Another big opportunity is utilizing big data right from the farm gate right through the supply chain to try to improve the efficiency and cost recovery, energy efficiency of their protein production chain. So that's another big opportunity that we need to look at going forward in Canada. So today I'll talk about what I categorize as two categories of alternative plant protein sources. The first one is underutilized proteins. So these are proteins from established sources that need ingredient line extensions. So we don't typically think of pea protein as an emerging source, but because it is small in relation to the whole market size, it is what I consider still emerging. Cereals, pulses, and oilseed canola protein is another good example of, or hemp protein, proteins that are emerging that need ingredient line extension. So there's products are already out there on the market. We need to create products or modify these ingredients so they'll be tailored to certain product applications so we can get more variety of our ingredients into the marketplace, which will then result in the increased market share. Another category I want to talk about is co-product utilization. So these are products left over from after processing. A good example is dry distiller's grain after ethanol processing, or canola or microalgae protein after oil extraction. So these products are agri-food byproducts that are rich in protein. They may be heat denatured, they may be processed more in a greater extent to obtain, say, oil, for instance. And then how can we make use of those other proteins? Now, we won't go through all these plant protein sources, but some of the emerging ones that consumers and industry are pushing for are rice. Oat has a lot of potential. Beyond pea, the other pulses, lentil, chickpea, especially faba bean, are really interesting and are coming down the pipes behind pea. Canola and hemp are also another important protein sources that are on the market or emerging, coming to the market. that will have a big impact, I think, on the food sector. Now, one of the challenges that we face in terms of getting plant proteins into the market and really influence decision makers and companies to embrace new proteins and move away from traditional soya proteins, we need to consider a number of factors: cost, functionality, taste, color. Supply is a really important one. We have to make sure if we're going to switch into a new ingredient, we have to make sure that there's a steady and consistent quality supply out there. How does it perform in new ingredients? And what are the health nutritional benefits of those ingredients? So these are all considerations that we need to take into account when we're talking to embrace new protein sources. Now, canola has some additional hurdles. They're typically lower in protein content than soya. However, we're working on breeding higher protein canola. They tend to have poorer functionality as soya. The amino acid content is a little poorer than soya. And typically, the meal is produced by desolventizer or toasting, which can be detrimental to the protein. So they could be heat denatured, which reduces their functionality. So we need to look at new processing capacity, whether it's membrane filtration, cold pressing. There's a number of research projects looking at trying to improve the utilization of canola meal because there's a big supply of it, and there's a big potential to capitalize on both the functional and nutritional properties of canola proteins. This is just a chart of types of commercial protein ingredients. So meal, and as we start moving away from meal, we start adding value. But we start adding costs as well, both in terms of processing and buying the ingredients for the food industry. So we see a spectrum from flour to dry process concentrates, so that's through air classification, wet processing concentrates and wet isolates, texturized proteins, all the way down to bioactive peptides, which are the highest cost to produce and to purchase. When we talk about protein quality, and I'll mention this a few times in the presentation, so I wanted to put a slide up here. Protein quality refers to the protein composition in relation to the essential amino acids that the human body requires, but also the extent of which it's uptake by the body to utilize for metabolic function. So that's a bioavailability. So there's two key components: the amino acid composition and that bioavailability piece. Now, protein quality is really important when we talk about labeling. And it uses various in vitro or in vivo models. In Canada, we use a protein rating, which includes the protein efficiency ratio, which is based on a rat model study, and also the recommended daily intake of that protein. PD-Cas is more internationally recognized. However, Canada also now recognizes, just recently, PD-Cas can be used as an evaluation of protein quality. And DIAS, which is another international approved method that looks at protein quality. Now, some of the downside about these are a lot of these are using animal models. And we're trying to move away from that to quicker, faster, and cheaper in vitro models. So Dr. Host is an expert and does a lot of work in terms of developing in vitro models to evaluate protein quality and moving away from the animal-based models. And again, different countries in terms of labeling base it on different protein tests. So it's important to realize what countries you're working with, how the labeling requirements are required, and what protein quality assays they're using as a measure of protein quality. So in this webinar, I'm going to talk about opportunities that I see in the feedstock quality, protein fractionation, so wet and dry, movement in the ingredient modification area, product development, human health, and social challenges. And all this really impacts the ingredient performance and opportunities within the research and development area in Canada for plant proteins and move this sector forward. So when we talk about improving the feedstock quality, A lot of the breeding programs that focuses on high yield and disease resistance. But now we're starting to see industry-driven, consumer-driven breeding programs changing to develop higher protein levels, such as canola and pea. We're working on a project raising the protein in pea from 23 to 26 here at the Crop Development Center in Saskatchewan. This is really important because we should be able to have greater protein extraction efficiency from the pea in the processing. Same with canola, it'll have higher protein content in the meal, which will make it more competitive against soya. We're also interested in, through the breeding programs, looking at changes in protein quality. A good example is, can we increase the sulfur amino acid content and tryptophan content in pulses to make them more nutritious? As you know, pulses tend to be deficient in the sulfur amino acids. So if we're able to develop and understand the mechanisms in which these amino acids are formed, we should be able to develop proteins of higher amino acid value. One example that we found out recently is chickpea. It was really interesting. Chickpea protein was a complete amino acid, had a complete amino acid profile when we looked at it from different sources a year ago, and it was because of the environmental stresses that changed the metabolic pathways of some of these amino acids, which created this complete amino acid. So understanding the relationship between the environment and protein quality is really important. We also look at potentially increasing the arginine levels in pulses, and this would be for a niche market such as for bodybuilding, where arginine is really important. So there's potential in the breeding programs to look at tailoring the amino acid profiles to certain end-use applications. And again, we're looking at quality screening assays, in vitro methods, using NIR to measure protein quality in the mass scale in terms of the breeding programs to try to help elucidate some of these issues. Another big opportunity coming down maybe five years from now is low visine faba beans. And this is really important because visine can cause in some individuals contribute to the disease favavism. So this is really important. And faba bean is really unique because it has a higher protein content than the other pulses. It's around 32% versus, say, pea, which is 23–24%. Another opportunity in the plant breeding area is enhanced micronutrients. So a good example is breeding low phytate pea to have higher iron absorption or more zinc in these things. And these breeding programs can help fight malnutrition in developing countries by changing the micronutrient load within these plant protein matrices. Another breeding area is reducing lipoxygenase activity for improved flavor profiles. As you know, plant proteins have distinct flavors that some consumers may not like. So looking at flavor reduction strategies is really important, and one aspect is through the breeding programs. When we talk about fractionation, both dry and wet, if we start off with dry, looking at the milling technology is really important to controlling particle size, and this can have a big impact on functionality. We're also looking at a project that looks at how the particle size impacts protein quality and the digestibility of it. So we're looking at different mills, whether it's a roller mill, hammer mill, pin mill, and what impact does that have on the functionality of these plant protein ingredients. Air classification is another dry process and produces a protein-rich and starch-rich fraction. The starch-rich fraction can have different levels of protein, and how can we capitalize on those ratios of starch and protein in that fraction for certain applications? So we need to do some product development and understand how the composition of these air-classified fractions impact the final use end product of these ingredients. Another area of research in the dry processing is electrostatic separation. This is a really interesting area in which it stems from the mining industry, in which they can add a charge by putting the flour through a turbometric electrostatic charger. and separate out the starch from the protein in different fractions. So it's thought that this can be used after air classification, maybe instead of air classification, but initial research is being done in that area for separating pulses, say pulse proteins from starches and cereal starches and proteins. When we look at wet fractionation, water and energy is really important for these big processors when we start making protein isolates. So reducing the water content and the energy involved is really important from a cost perspective and sustainability perspective. There's some opportunities for flavor reduction strategies, whether it's using a thermal method, alcohol, or using absorbent resins to move these flavor compounds or notes from these pulse or plant protein ingredients is really important to make them more bland or that consumers will take advantage of. Another unique opportunity is, and I'll show you a slide in a minute, about developing specialty fractions with unique protein profiles. So we can pull out a fraction and modify the protein profile in the wet extraction process to obtain different functionality. And then that will lead to different product development applications. So also using a combination of dry and wet fractionation processes to enhance the initial protein levels going into the wet fractionation process to make it more efficient. So this is an example of a typical pulse protein isolate process using alkaline extraction, where you solubilize all the proteins that you want, and then you remove the insolubles from centrifugation, the starches, fiber, insoluble proteins. Now what's interesting is that that protein solution, this is where we can do the specialty fractions using membranes or pH precipitation methods or salt precipitation methods to get unique protein profiles. It's also an opportunity in which we can add deflavoring steps like resins to absorb some of these flavor notes and treat these protein solutions before we acidify them and collect the protein solids to get your protein isolates. So lots of opportunity in the wet extraction process to modify it moving forward. When we talk about processing plant proteins, even though protein is a high value application, to make the whole process more efficient and cost effective, we really need to consider the starch and fiber co-product stream and how is this being utilized. We need to start adding value, especially to the starch. There's so much of it arising from the dry processing or wet processing area. How can we use that? How can we add value to that starch application for food or feed applications? Another area is fermentation and enzymatically assisted wet fractionation. So I mentioned canola meal or dry distillers grain. These byproducts could be heat denatured in that process or alcohol denatured. So using fermentation and enzymes to break up some of these protein starch or protein fiber interactions is really a potential opportunity to extract more protein and to reclaim some of that value that we lost during the high processing of these materials. When we talk about ingredient modification, we're talking about ingredient line extensions. How can we extend protein ingredients so they can be start tailoring to certain applications? So a good example is pea protein. Right now there may be 4 or 5 different products on the market, but if we use processing to tailor their functionality, we can start having protein ingredients that are better used for beverages or better used for baking or as meat analogs. So there's a number of different processing methods listed here: cooking, roasting, high pressure, microwave cooking, infrared heating. There's a really great company, Infrared Products, here in Saskatchewan that does a lot of great work in that area. Extrusion. But all these processes work to change the protein structure, whether it's the coronary, tertiary, or secondary structures. It changes the level of denaturization in the product, exposing buried hydrophilic and hydrophobic amino acids, which then change the surface chemistry, which then changes the functionality and ultimately their product development and product performance. So there's a number of opportunities that we can use in the processing side to alter that functionality, flavors, and reduce the protein quality, or change the protein quality of these. These processing can be used on seeds, flours, and concentrates depending on what processing method we're using. Now, when we talk about protein functionality, it's important to know that when we're using processing to modify it, it could have a positive, negative, or neutral impact on protein functionality. So we really have to understand the processing and how those will impact the protein structure and its performance. Now, this is a really busy slide, but what I wanted to highlight is how we can modify or tailor the functionality of these protein ingredients for product development. So we have intrinsic factors. So these are factors about the structure of the protein itself. Extrinsic factors are solvent effects that we can change. So the chemistry of the food matrix, so the pH, salt, temperature, can have a really big impact on how these protein ingredients behave in food products. And then we already mentioned processing factors that can be used to modify the structure of the protein. This is just an example of how we can tailor functionality using pH and salt as an example. So here's an example of pH away from the isoelectric point. So there's a lot of repulsion going on between proteins. And in a situation where that occurs, it's better solubility. It improves it for use in beverages. It tends to be increased water hydration or binding, improved emulsification. We can control the gelation properties, so the aggregates forming the gel network, and reduce foaming. But when we look at the reverse, where pH is near the isoelectric point, or there's high salt, so there's lots of protein attraction, we have reduced solubility, so it could be good for meat applications or analog applications, poor protein hydration, water binding, poor emulsification. Again, we can have controlled gelation and improved foaming. So by controlling the pH and salt levels, we can achieve different functionality and obtain different product applications for those ingredients. Another way that we can tailor protein functionality is using polysaccharides. So this is an example in the pictures of an emulsion, in which we have oil droplets surrounded by, in figure A, a protein polysaccharide mix layer, and in picture B, we have a bilayer type interface. And by controlling how these interfaces are formed, we can control the emulsion stability, but also if we want to make microcapsules to deliver bioactive compounds, we can control the release of these compounds for supplement delivery or drug delivery. So adding polysaccharides can have a big effect in the food matrix, determining their functionality. Another really interesting thing is blending of proteins. So we know pulses are rich in lysine and deficient in sulfur amino acids, and the cereals are opposite. So blending pulses and cereals to make blended protein ingredients is really an opportunity, I think, to optimize their amino acid profile and their protein quality for food applications. So we'll be looking at more blended protein ingredients in the future going forward to get that more complete amino acid profile. This is another busy slide. I just wanted to highlight some examples. When we talk about solubility, pH and salt are big considerations. High solubility is great for beverages, whereas low solubility is better for meat analogs. So different functionalities can have different considerations, using it to tailor to different applications. So a lot of opportunity to understand how functionality impacts product performance at the other end. So some of the challenges when using for proteins for product development, protein ingredients from different companies differ because they use different protein methods, separation methods. So for example, pea protein from one company could be completely different from another company. So understanding the process of how these ingredients are performed are important. It's also important to understand protein functionality specifications from companies, because there is no standard methods for functional testing. So having an understanding of what methods they use is really important to understand their values that they're reporting. And just because an ingredient is high in protein doesn't mean it has high bioavailability. So it's important to look at those and ways we can enhance that digestibility of that protein. Some solutions are to know your process and product. Test an array of protein ingredients from different suppliers. Use in-house testing methods, or there's a couple standardized methods. Solubility is becoming more standard. Water holding capacity is becoming more standard. But use in-house methods to evaluate different protein sources for your own applications. And seek support from universities or government labs. There's a lot of help out there, and industry just needs to realize who to contact and network to get the advice that they need to help solve some of their problems. When we talk about health, some opportunities associated with health outcomes and firming up what the consumption of plant proteins have on these health promoting properties is important. And I'll talk a little bit on the next slide about the metabolic syndrome and how can we improve or obtain a metabolic advantage by consuming high protein content, good sources of protein with reduced glycemic indices to help against obesity, high blood pressure, and others. So metabolic diseases, and understand more of what are the long-term consumption of risks of metabolic diseases. And as we know, metabolic diseases are a precursor to chronic diseases like cardiovascular disease, diabetes, and others. So what effect does consumption of plant proteins have on reducing the risk of these diseases? When we talk about metabolic syndrome, so about 20% of adults have one or two of these symptoms: insulin resistance, high blood pressure, high triglycerides, low HDL glycerol, or visceral obesity. So consuming plant proteins will help reduce the risk of metabolic syndromes. We have to understand how it does and the mechanisms involved, and hopefully then reduce the risk of cardiovascular disease or other chronic diseases. And understanding that health linkages is really important. There's also some social issues that are really important and some opportunities for the protein sector in Canada. We need to analyze what other countries are doing in terms of their protein supply chains, their focus. So a lot of work with the protein superclusters, understanding a lot of ecosystems being developed in other regions of the world, and how can Canada capture some of the advantages of and knowledge from their networks. We need to conduct a critical policy analysis and understand policies associated with plant protein production, processing, consumption, and the environment. And we have to foster environments, food environments that promote healthy eating and plant protein. So we're not just going to tell someone to consume more plant protein. We need to change the food environment to make it more likely to consume plant proteins in the diet. So make it more change in the food environment rather than telling someone just eat more plant proteins. We need to engage Canada's multicultural population and understanding these different food environments from different cultures. A lot of other cultures are more on a plant-based diet, and try to understand how their diet can be changed into the food environment into Canadians' diet. We talk about enhanced processing capacity across Canada. So there's a number of big investments from a number of companies: Roquette, Verdient Foods, Grain and Pulse Solutions, Richardson's, Merit Foods is another big processing facility coming online, and as well as a number of other smaller companies looking to invest in the dry and wet processing facilities across the prairie provinces. So we're getting capacity to do that value-added processing, and we're working forward to moving forward in terms of enhancing this processing capabilities of Canada. There's a number of research capacity investments across Canada. Protein Industry Canada, Supercluster. There's a number of Canadian agri-science cluster initiatives. Provincial and growing funding research is really important and fundamental to a lot of the protein research being done across the prairies and in Canada. One big area of interest is the food centers in Saskatchewan, Alberta, and Manitoba. There are others across Canada, but they're doing a lot of work with companies, helping to translate science being done at the university, helping companies problem shoot to develop new products and processes. So these centers are really great to engage with across Canada to help with those product innovations. And then we have the NSERC Create program, which is a federally funded program, which I'll talk about in a second. Another opportunity is looking at advanced labor force. A number of gaps have identified within the NSERC Create program, hands-on industry experience, communication skills, project management, effective writing, leadership. So part of this NSERC Create grant, which is titled Capture, which is the name of our seminar series, stands for Canadian Agri-Food Protein Training, Utilization, and Research Enhancement, focuses on adding value to young scientists by combining technical, leadership, and business skills to help drive economic growth in the plant protein sector. So the program trains about 71 trainees, so graduate students, with this business and leadership training. And it spans the U of S, the University of Alberta, and University of Manitoba, and it's valued at $3.8 million. So it's a big project, all focuses on training through this process. So to sum up sort of this webinar, I think it's really important to look at building the ecosystem between universities, government, and industry, and work together to try to develop ingredient and product innovations to push the protein ingredient sector further in Canada. We have a lot of capacity, a lot of support from both government and industry and universities. So we really need to access this and build this network within Canada to capitalize and build our sector as we grow. So if you have any questions, Jim will read them through the chat. You can also contact me by my email, and there's my webpage, and thank you very much.
Great, thank you very much, Mike. Excellent presentation. We now have time for some questions from the audience. I will keep track of the chat feature. If you would like to pose a question in person, as it were, there's a feature that you can just raise your hand if you go over to the participant feature, or you actually, I think it's probably set up primarily for the chat feature. So why don't you go ahead and enter your questions within the chat feature. I have a question here from one of the attendees regarding breeding opportunities. Is there any specific approach for hemp protein from this perspective? Are you aware of work that's happening on the hemp side with respect to breeding protein quality?
I'm not aware of on hemp in terms of breeding quality. There is a lot of processing being done on the processing side. Key Leaf Life Sciences here in Saskatchewan is doing a huge amount of work on the processing side, but I'm not aware of any on the breeding side. But the crop development here would be a good contact to check into that a little bit further.
Great, yeah, certainly there are some initiatives around hemp breeding across the prairies and also into the northern US as well. But I think primarily it's been focused around some of the agronomic traits, yield, disease resistance, and I think it's a new era for looking at sort of these more phenotypic traits that link to nutritional and functional attributes. I think it's a really exciting area. What do you see are some of the greatest opportunities that we have right now in front of us in the next, say, 5 years, Mike, for advancing this sector?
I think I think the processing side is going to be really important in the ingredient modification side over the next 5 years. We have a lot of companies coming on stream in terms of making these protein ingredients. And as they start moving those ingredients into the marketplace, they're going to come up with a number of challenges in terms of product development that we're going to have to address through ingredient modification to make it and tailor the functionality to help troubleshoot some of their applications. Besides processing, I think there's going to be a lot of work in terms of product development, egg replacers, non-dairy milks, and the meat analogs are catering to those sectors. So there'll be a lot of work in that over the next 5 years for sure.
No, absolutely. We're getting lots of questions posted, and certainly keep the questions coming in the chat feature. I'll try to keep up. So one of the questions is around the measurement of protein. So standardization of techniques. It's certainly an issue that we do have standardized techniques for example, AOCS or AOAC have standardized techniques. I'm just wondering if you comment maybe around some of the challenges that you may have experienced or suggestions you might have for those in the audience today about the need to have sort of standardized techniques when looking at either protein content or functionality or quality measures.
Yeah, in terms of the protein content, there's two main, and these are standardized through the American Oil Chemist Society, also I believe the Cereal Chemist Society, but using LECO combustion method or Keldol to determine the protein content. So these are standardized methods for determining protein content. Protein functionality is a whole different area. There's lots of variability in terms of the equipment that you use to measure the functionality. But there are some work. The Canadian Grains Commission just came out with a lot of work from Dr. Ning Wang on the water holding capacity, a standardized method that's been approved. Solubility is becoming pretty standardized, but things like emulsification and foaming, there's a lot of variability in the literature and in industry. So understanding what methods are used and testing those are really important.
Great. Pull up some other questions here. Now here's a comment that's I'll pose it to you and see if you have an answer. You'll be basically making millions overnight. But in essence, when you look at farmers in terms of how they make decisions around plants or crops that they plant, it's typically guided by yields. It's guided by the price points around how we are the current system, how we market crops within Canada. Not a lot of attention is paid to nutritional or functional characteristics. I think the one exception you might have is for wheat. But I'm wondering some of these traits that you've talked about, functionality, protein functionality or protein quality, what would it take to get that advanced into the pricing scheme for crops going forward, or would you see a different approach?
Well, I think this is kind of a more longer-term, industry-driven answer. So I think at some point, a good example is if we can develop high-protein pea, or maybe pea with a certain amino acid profile that are higher in sulfur amino acids. So if we can develop a variety that industry wants more, so they preferentially select it, we could see sole sourcing to producers to produce this. So I think industry eventually will start driving certain cultivars over the other because it'll enhance processing or enhance nutrition for their end use application. So we're not there yet, but I think the industry at some point will be moving towards that 5 or 10 years down the road, in which these big companies are driving certain varieties over others, and so they'll be sole sourcing or paying a premium to get a certain value there. Great.
Questions around your reference to the chickpea protein content and amino acid profile. There's a couple of questions coming up about that linkage to abiotic stress. I'm wondering if you can comment further, and specifically if there's any references that you can point to in that area.
Well, I guess if you send me an email, I can send you some paper references. We were looking at chickpea as part of a food security project. And we were looking at both Desi and Kabuli chickpea. We looked at different sources or obtaining them from different certified seed growers. And the idea in this particular project, we're looking at using processing to improve their nutritional value. And what we found was they're pretty nutritional as is. They're a complete amino acid profile starting with. And so we hypothesized this was because environmental stress, there was a drought that year, and it may have changed in the seed the metabolic pathway to produce more of the sulfur amino acids. So we're looking to develop a project to look at that further, but we think environmental stresses can alter the metabolic pathways and synthesis of these amino acids to change this. So it may have been a blip in that year, we don't know yet, but understanding that environmental linkage between the seed and that protein quality piece is really an interesting and opportunity to look forward.
Great, great. Yeah, no, certainly I think there's a lot of opportunity to look at the greater interaction between genetics and environment on both functionality and on quality measures. There was a question here about, a very specific question about breeding efforts to narrow the isoelectric point of proteins for easier isolation by wet processing. One of our protein chemists is asking this. Are you aware of any efforts there, or even some research in terms of how one might address that particular challenge?
I'm not aware of, this is the first I've heard of that. I'm not aware of anyone trying to adjust the isoelectric point. There's some work in terms of trying to understand how can we have more globulin proteins versus albumin proteins and modifying the protein profile. But I haven't seen any reference to anything about the isoelectric point of a protein for better extraction. Okay.
Question about the use of co-products from the processing sector. Certainly that's a challenge for when you're looking at, and an opportunity, I guess, when you're looking at co-product utilization from protein isolation from our prairie crops. What about the use of other co-products from other industries, like, for example, distillers' grains or other co-products that you might find from processing that might serve as a substrate for protein isolation? Any comment there?
Yeah, no, I think, you know, I usually talk about food. You know, some of these other agricultural byproducts may not be food grade depending on where they come from. But a lot of the protein science translates and to knowledge that could be used for biomaterial research. So non-food applications. And so some of these highly degraded proteins or proteins that may not be necessarily food grade, for instance, they came through an ethanol processing plant, we can look at trying to reclaim some of the functionality of those proteins through enzymatic modification or fermentation and use those proteins for non-food use in applications.
Okay. Yeah, thanks for that great answer. Just looking here for a couple more questions as we approach the top of the hour. There's a question here about the stability of the proteins under different conditions and different applications. Just wondering if you wanted to comment about any issues with respect to shelf life, oxidative stability of the proteins, be they in a sort of a solid or bar format versus a beverage format, and what steps one might be needed to ensure that you've got stability from a functionality standpoint as well as from a nutritional standpoint.
Yeah, no, that's a really good question. It's a really loaded question and hard to answer. When we talk about obviously a beverage application, we want enhanced solubility of the protein. So we don't want insolubles floating around or forming a layer at the bottom. So it's really specific for a certain application, whether if it's meat analogs, we want high oil and water holding capacities. So there's different environmental or processing factors that can come into play in terms of the stability of the product. There hasn't been a lot of work on, surprisingly, the storage stability of these protein ingredients. So that's one thing that we need to look at is over time, how long can we store and what conditions can we store these ingredients for? So it's really, stability is really product specific about the stability of that protein and how it will perform.
Yeah, because certainly when you look at certain protein isolates, while the raw commodity or the ingredient commodity might be very low in lipid, once you isolate it, that lipid is also co-isolating with the protein fraction.
Yeah.
You might have issues with the lipid stability and not just the protein stability. So it's a really important question in terms of shelf life. So thanks to the audience member for positioning that. Here's a challenge to the capture program. So there are food competitions across North America and the US. That certainly you're involved in one with the CIFST program. Do you see an opportunity, for example, to capture to have a regional food program or protein foods competition? Maybe pit U of A, U of M, and U of S in competition or even work collaboratively in a pan-provincial type of approach. What are your thoughts on that?
I think it's a great idea. Sort of the fundamental reasoning behind the capture program is to build this ecosystem and network. And from this, we want to promote the leadership of our young scientists and students. So engaging in an activity with individuals from different universities to come up with solutions or new product development, for instance, would be really engaging for our students. And it's a great idea that I'll definitely take back to our group and consider, because I think anything that promotes leadership or group activities and networking is really at the forefront of the capture program.
Super. Lots of questions about whether or not the presentation will be available to share. And I note from Lenore, who's the capture training coordinator, that the webinar will be available on the Create website at pletproteintraining.ca coming soon. And so certainly keep an eye out for that. And I'm sure that you'll receive more information from the capture program on additional opportunities and additional webinars coming up. Maybe one more question before we do just a final wrap up. Can you recommend any resources for comparing and learning about protein functionality and the protein isolate process and fractionality? There's a lot of, I think there's a lot of opportunities to provide that information, but anything that comes top of mind that you might recommend as a good starting point for those that are interested?
Well, in terms of protein functionality, on my website, www.saskproteins.ca, we have YouTube videos describing step-by-step methods. We're also going to be launching a protein functionality methods-based workshop, maybe even next month, March or April, through the capture program to help train industry and students. How do we actually measure protein functionality? In terms of extraction, there's not really, I could send, if you send me an email, I can send a number of publications that look at extraction, but there's not necessarily one sort of site or resource to sort of outline what extraction processes or dry extraction processes.
Super. Well, Mike, we've reached the top of the hour. On behalf of the participants in today's webinar, I want to thank you for presenting this an excellent talk and for answering questions from those that are attending today. As I mentioned, this is the inaugural webinar in our Capture Program series. There will be webinars upcoming. I don't know if you wanted to just take a quick minute to just maybe mention about the series that is planned.
Yeah, so the last Tuesday of each month, we'll be having a guest speaker or webinars on different topics in terms of in the food. Oh, here we go. In the food protein space. So the next one is March 30th. Super Team Gosh, and he's going to be talking about plant protein stabilizing emulsions. And then we go through all the way to September with different speakers. And then after that, we'll probably have another set of speakers lined up for this. So every Tuesday, information will be sent around in terms of registration, similar to today, and we'll go forward with this seminar series.
Super. Well, thanks very much, Mike. And to the audience, thank you for your attendance and for your excellent questions. And we look forward to seeing you again in a month's time from now for our next seminar session. So with that, I will bid you all a good day.
Perfect. Thank you.